Welcome to another episode of AI with Sally, an EE Times podcast that brings you inside my conversations with luminaries of the AI chip industry. Optical I/O company Ayar Labs is 10 years old this month. As AI inference at scale begins to demand very, very large computers with very fast communications between chips, finally we're at the stage where copper simply can't keep up. This is a killer app for Ayar Labs and the timing is perfect. At this point of inflection for the company, I had a chat with Ayar Labs co-founder and CEO Mark Wade. Mark and I talked about the company's beginnings 10 years ago as a joint project between universities with some of the industry's most prominent academics to guide it, through the challenges of trying to raise funding, to building a supply chain and an ecosystem for a totally brand new technology, all the way to today's market opportunity with the impending scale of LLM inference. Here's my conversation with Mark. Okay, hi Mark, and welcome to the show.
Hi Sally, thanks for having us and glad to be here.
So congratulations, it's Ayar Labs' 10th anniversary. Maybe you could just take me right back to the beginning. Whose idea was it to start a company? What was that initial idea and how did the whole thing start?
Yeah, and one, thank you for the congratulations. And it is strange that we're 10 years old. It's gone by, on one hand, it feels like it's been a long time. On the other hand, it feels like it's been a blink of an eye. The company has been around for 10 years now, but I tend to think of the journey so far as at least my own role in it being closer to 15 years. And it really goes back to around the 2010 timeframe when I was graduating from undergrad and going into grad school. And when I was going to grad school, I was trying to find something, of course, that seemed interesting to work on. That was a good mix of, I was really into physics at the time, and I was kind of coming from a physics foundation, but wanting to get a bit more applied. So looking on different projects and trying to understand what different groups were working on. And I was lucky enough to kind of find the budding field of silicon photonics at that time. And I got plugged into a big collaborative effort that was going on at MIT and Berkeley and some work happening at the University of Colorado Boulder. So these were the labs of Professor Rajiv Ram at MIT, Vladimir Stoyanovich, who was at MIT at the time. He later moved to Berkeley. Then my PhD advisor, Milos Popovich. And really what they were doing is that they were amongst some academics at the time that were spending a lot of time plotting out trends of different pieces of computing technology, trying to understand the kind of fundamental scaling of things like transistor density, where Moore's law was going, how that translates into flops per chip, looking at how it's balanced across the other key components of computing systems. So chip-to-chip I/O, memory bandwidths, memory densities. And one thing that was recognized early on was that as we got into the 2020s and the 2030s and probably beyond as well, there was this growing gap between how many flops you could cram onto a chip versus how much bandwidth you could push in and out of those chips. So we worked on kind of solving that problem in a new way, using silicon photonics. And it was really myself and one of my other key co-founders I was working with in grad school named Chen Sun, and the professors who thought that the results we were getting, the approach we were taking compared to where the industry was at was unique enough to go say, hey, let's go try to put this into a company. And we thought we could accelerate progress and have an impact on technology. So that was kind of the original idea, I guess.
I mean, in terms of technology, what was you kind of identified this problem and then developed technology to kind of meet it? Was it that way around?
Yeah, I think on the academic team that I joined, and I feel incredibly lucky to have somehow stumbled into this team. Really, there was a combination of multiple domains of skill sets that came together. I think in an abnormal kind of academic collaboration. So you had Vladimir Stoyanovich coming from a high-speed electrical links background. For those who care about tracking lineage and things, he comes from the kind of Mark Horowitz side of things and who was one of the founders of Rambus. So deeply knowledgeable and had deep insight into how electrical links were performing in high-speed SerDes and things. You had Rajiv Ram, who was coming from the kind of semiconductor optics side of things from the John Bowers UCSB school. And that really brought a a kind of capability on how photonics and optics could solve this. And then my PhD advisor, Milos Popovic, came from Herman House's group at MIT, another kind of deep silicon photonics thinker. So yeah, I'd say it was identify the problem first, which is that we're approaching a time where connectivity is not scaling and keeping pace with what the compute chips actually need and the processor chips. And then kind of work backwards from that problem statement. As limited by the laws of physics, what kinds of technologies can solve the issues that electrical links are facing? What kind of bandwidths are we talking about? Energy efficiency was a big focus and still is a big focus. And the scaling of these technologies as it relates to how you go manufacture them in CMOS processes. So it really was kind of saying, well, we first have to start with a level of, let's just start with a blank sheet, and you are constrained on some things, like you have to go build things in foundries that can actually produce things. But it was a kind of a blank sheet of paper saying, let's start choosing to develop the right technologies that address the right kind of scaling pain points that these projections are predicting.
So I understand one of the early papers, or maybe even the first paper that came out of your group that was working on this, was you were the first to demonstrate optical communication between compute and memory chips. Have I got that right? Was that one of the earliest? Or that seemed like a kind of a milestone to me.
Oh, it's definitely a milestone, and it was a kind of culmination of a lot of the work that myself and my co-founders and the professors were doing, as well as just a phenomenal set of graduate students and postdocs who were working on these projects at the time. So it was definitely a big collaborative effort. And yeah, we were the first to build an optical connection between a microprocessor chip and a memory chip. And so the early focus back in that kind of 2010 to 2015 timeframe was to build photonic links between processors and memory, as we were focusing on that as a key part that was struggling to scale. And there's so many kind of fun stories that I could tell about during that time, because we actually hacked photonics into an IBM SOI microprocessor process at that time. We had to reverse engineer all the PDK files. This was not a process that was meant to build photonics. I spent a lot of my time digging through caliber decks and trying to understand all the way the Boolean operations were working and mask generations. And then we kind of deconstructed all of that and were able to build photonics in that process without support from the foundry. So we went and built these microprocessor chips with silicon photonic links on them. And it led to the first demonstration of optical links between compute cores and main memory. Another kind of fun fact that you might appreciate, if you look at the co-authors of that paper, there are really two companies that spun out from that original work, because those were also the first ever RISC-V chips to work in silicon.
They were? So okay, I didn't know that.
So the founders of Sci5 were our co-authors on that paper. And so you had Ayar Labs kind of spin out to really go focus on building silicon photonics and optical I/O. And you also had like Kirste Asanovic, Yunsi Andrew Waterman, who spun out and went down the Sci5 and RISC-V path. So that's kind of an interesting trivia point, I guess.
It's more than trivia. We're talking about the invention of some of the most important things in computing. Okay. A lot of startups never make it past that initial stage. Doing deep tech startups is really, really hard. What would you say were the biggest challenges kind of getting this young deep tech company off the ground?
Yeah, it's a great question. And it's one of these things to where I think there's definitely, you have to have a certain amount of naivete, I'd say, to jump into these kinds of efforts, because you really don't have the full picture in your head on what it's going to take to get it off the ground. But I think one of the wonderful things about founding teams that works are people who just simply refuse to give up, kind of wake up every morning and just keep grinding against nearly impossible challenges. I think in the early days of Ayar Labs, especially kind of in the hardware area, it was a very different time than now. One, silicon photonics specifically was a deeply unpopular area of technology. And we didn't quite realize this until we came to Silicon Valley and started pitching the kind of Sand Hill Road suite of VCs. And silicon photonics, connectivity, things like optical transceivers, a very unpopular thing to be pitching as trying to get a company off the ground. So we actually struck silicon photonics from all of our pitch decks.
What?
It got so quickly dismissed. If we said, hey, we're working on silicon photonics, boom, you're done. Like I think, I
like
won't
the
name
opposite
names.
of a buzzword.
No, that's right. It was like an anti buzzword. I won't name any names, but I remember one example is kind of steered in my head. We had one investor say, I'd rather open a grocery store than invest in silicon photonics. And so,
oh God.
So
that is absolutely crazy. Well, I hope he's doing well with his grocery store.
That's right. That's right. So yeah, I think, one, and look, the reason why it was deeply unpopular at that time was because that era of data center architectures, of hyperscaler kinds of downward pricing pressure, connectivity did not have a unique value in that era of data center architectures. So whereas we were talking about this kind of trend line that was going to be coming, that was going to bottleneck everything, I'd say the market intelligence at that time just thought about, everyone saw the big push from places like Facebook and Google to, there was a mantra at OFC during those years, $1 per gigabit per second for 100 gigabit per second optical transceivers. And so there really was this kind of, you had concentrated buying power at the hyperscalers. They were forcing all the transceiver companies into a really challenging kind of commoditized form factor. So it was a tough time to be talking about kind of connectivity and photonics. Now we were saying, well, we're not building any of those transceivers, and we're drawing all these trend lines that are showing that the 2020s and 2030s are going to have a widening gap of bandwidth needs and how the different elements of compute systems are scaling. I understand why it was so unpopular at that time, and we had to find a way to pitch our story. And what it really resulted in is we had to find the right investors who were not just, you'll find most VCs in the Valley are just thematic, or are just kind of following thematic trends that everyone else is following. And so for us, what we had to go do is we had to find the ones who were thinking from their own perspective and understanding what we were doing deeply enough, and then thinking through the story we were telling deeply enough to say if they thought it was credible or not.
Yeah.
And I will say that that's the minority of investors, but we were lucky to find Founders Fund in our seed round, which is really what got us off the ground, and then Playground Global led our Series A. And my experience with both of those firms was that they fit the kind of category of willing to think from their own, use their own brain to think about how they evaluate companies and how they're evaluating ideas. So yeah, that was a fun time, and I learned a lot during that time. Yeah.
Do you think these same kinds of challenges apply kind of 10 years on to companies, or people are thinking of starting companies in the deep tech and the semiconductor industry? You still need tenacity, I guess, and you still need VCs that are forward thinking enough to appreciate your ideas and believe in the technology, right?
Yeah, no, that's right. Look, I think starting a deep tech semiconductor company, especially, I kind of categorize them in a couple of different areas. You've got plenty of chip companies that start that have think that they have an interesting chip level architecture, but really what they're doing, and I think there are interesting things happening there, but they're building on top of a very stable set of chip design infrastructure that the industry knows how to use. So, if you and I came up with an interesting, kind of compute and memory accelerator architecture, and then we were able to kind of go build those chips using the existing ASIC services and existing, we're going to try to use the latest and greatest TSMC or Samsung digital process. That's one version of kind of deep tech startups. And look, I think those face incredible challenges as well. I'd say the kind of unique set of challenges we face is we actually are innovating in the process itself. So we were going and building devices in the front end technology and essentially building a new layer of kind of front-end integrated devices going into the most advanced CMOS process nodes or integrated alongside the most advanced CMOS process nodes. And so I kind of, the list of challenges is immense, and I bucket them into a few different areas. There's the challenges of fundraising and trying to find a story and a product market fit and an overall pitch that resonates with enough investors to get capital to do something with. And that has its own kind of unique set of challenges. But as we get into the deep tech semiconductor side of things, okay, we are in a time right now to where, it's funny. So we struck silicon photonics from all of our pitch decks in 2015, but by 2022, 2023, the investment world is rediscovering this new sexy technology called silicon photonics. So, silicon photonics is back on the pitch decks, let's say.
It's not an anti-buzzword anymore. It's like now foundries even support it. It's like you've done all the hard work.
That's right. So it's now a buzzword. But, I've now been working on this long enough to see the buzzwords and anti-buzzwords, kind of go in and out of phase a couple of times. So but the harder thing about the semiconductor ecosystem is the supply chain, the tool sets that you engage with, the design methodologies are incredibly expensive, capital intensive, and I'd say difficult to access. And I don't think it's not a statement that the semiconductor industry has done anything wrong to kind of fall into that kind of structure. It's it more comes out from, hey, there's only a very small number of advanced foundries on the planet: TSMC, Samsung, Intel Foundry, and then everyone else is kind of a distant kind of set of players. So you have immense concentration in the supply chain, and also the business model that allows those foundries to keep their businesses flowing really depends on scale. So scale and volume and substantial numbers of units that are flowing. So yeah, I think we could go on and on about where the difficult problems are. And I do say, I was talking to another kind of entrepreneur a couple of weeks ago trying to do something similar in this area. And I think the way I put it is getting a startup off the ground in the semiconductor industry, and then especially getting it to like a late phase, I would say is very nearly impossible. And now I think that then separates kind of entrepreneurs into two categories. I think, if you're scared by that, it's probably a good indicator that maybe you don't want to start something. If you have a little bit of, I'd say maybe arrogance is a good word here, or some combination of naivete and arrogance to say, we're still going to try, then I think that it's worth trying. Right?
It's worth doing.
Yeah.
So one of the biggest challenges I think you faced over the 10 years is that commercializing something completely different like this, a brand new technology, needs a whole ecosystem. We're talking about foundries, but beyond that, there is a whole ecosystem. You're setting up a whole supply chain. How successful have you been at developing this kind of supplier and partner ecosystem over the last 10 years? And how difficult was that as a problem to do?
Yeah, that's a great question. And I will say, I think that question touches on the core strategy that Ayar Labs has been running really since we started the company, even still in grad school. We did have an early insight in grad school to recognize that there was this huge gap between the kinds of technology demonstrations you'll see in labs like MIT and Berkeley and Stanford, and how exciting and impressive some of those technology demonstrations can seem. And then you'll see lots of articles written about them because you publish in Nature and it all looks very exciting. But then we recognized the massive gap between what's happening in the labs of universities versus what's actually shipping in production. And then just asking the question of why is there that gap, it leads you to saying, hey, look, the hard problem is, I don't want to dismiss what happens in universities because there's a lot of hard work that they're doing as well. But I'd say the harder problem is figuring out how to make technology progress and really bring it to production and build a go-to-market, supply chain, and ecosystem partners, and make sure that you're finding the right business model, the right collaborative approach to get everyone to help you pull the technology progress through. And so we had that insight very early in school, and then we focused on saying, well, if we're ever going to get photonics into high volume, really it kind of boils down to, or one of the key problems it boils down to is are we building the right ecosystem and the right supply chain partners? And I'll give an example of how that turned into decisions on our side. We've actually never built a chip in a research foundry. And so we kind of ideologically almost said, hey, we're not going to go build chips in research foundries. And, I want to be careful there because I think research foundries are doing good work as well. But
absolutely, yeah.
Startup building a chip in a research foundry, it's not yet working on the hard problem of how do you actually transition that work into a production foundry environment. So we focused on day one of, even though it's a very hard problem, we focused on building the right relationships with foundry partners who could conceivably scale. And so what did that look like? Very early on, Global Foundries was our first foundry strategic partner. That was 2017. Intel Capital came in 2018. And Intel Capital really brought all of the other vertically integrated pieces of how you need to go build multi-chip advanced SoC packages. So we were doing the silicon photonics chip on the Global Foundries side. And then Intel had all of the other pieces. And they had a really compelling advanced package platform, which some of the stuff we have shown publicly, you have TSMC silicon in the middle of that package. You have Global Foundries silicon from the photonics coming from Ayar Labs. You have Intel Foundry built chiplets, and you have an advanced Intel Foundry built package. So between Global Foundries and Intel, it allowed us to kind of bootstrap all the pieces. And once we had those partnerships, it sponsored us into places like the Taiwanese ecosystem. So it kind of helped build a cascade of a domino effect on getting other key players in the OSAT community to engage with us. And if you just play that story forward now, we have a long list of strategic investors and collaborators and kind of product development partners. So NVIDIA, AMD, Intel, Applied Materials, Hewlett-Packard, Global Foundries. We work closely with TSMC. And then underneath that, we're engaged with all the major test vendors, all the major OSATs. So I think that has taken a decade to really kind of build out to in completeness. But I think there's no fast way to go do that, especially as a new player trying to build a new technology. So we really stuck to a year after year after year. It's been one of the foundations of what we've focused on, building this ecosystem and building the right manufacturing and supply chain partners.
Yeah. I think when you and I last spoke, which was probably around September, we were talking about tokenomics. So the economics of producing LLM tokens at very, very large scale in an AI factory, as Jensen calls it now. This is obviously going to be a killer app for Ayar Labs and for your technology, but this definitely didn't exist 10 years ago. How has your mission evolved over 10 years with the change in application space?
Yeah, it's a great question, and I get asked kind of what pivots have we made, and what were the twists and turns along the path. Interestingly, technology-wise, it's been pretty stable in terms of the trends that we were betting on in technology and developing at the core. It's been pretty stable, but the product market fit and what application was going to emerge as the commercial application that could drive enough scale and volume and value to accelerate the adoption of a new generation of photonics, that's taken multiple twists and turns along the path. And we had to make some early bets. But I think there is a through thread in how we thought about it, because when we spun the company out of university in 2015, and we were still students when we started the company, we were first focusing on high performance applications. So we did recognize, for all the reasons we talked about earlier, why transceivers did not have a great kind of marketplace in data centers at that time. The application in data centers, which was the volume application, was not driving value. But connectivity in high performance computing workloads was critical to the performance and the scalability of high performance workloads. And so we were actually focusing on what was a bit of a niche domain of high performance computing, which at the time was being largely driven by companies like Cray and Hewlett Packard, and you had the first systems that actually kind of set the foundation for how the AI systems are being built now. But Intel would supply into those, AMD would supply into those, NVIDIA started supplying GPUs into those. But they were really the buyers were places like big national labs, right?
Yeah.
So it just wasn't. The challenge at that time, 2016, 2017, was we had a clear value story for why interconnect had differentiated value in high performance computing workloads, but it was missing the volume. There was no volume in high performance computing. And so you couldn't really get the attention of the supply chain that you needed to kind of help get behind it. Now in 2018, when we pitched our Series A, we pitched it on the largest opportunity in the data center was going to trend towards AI workloads, and what we were calling rack scale AI compute systems were going to be the biggest opportunity in the data center. And for rack scale AI systems to scale, they were going to have optical connectivity. And really all we were doing at that time was taking all of our technical and architectural understanding and intuition that we'd developed focusing on the high performance computing application. And we realized that there was a convergence happening to where the AI workload was turning into a high performance compute workload. And I will say in 2018, very few investors thought that this was a credible market story. That was pre-Transformer, that was kind of pre-BERT.
Yeah.
But we were already starting to talk to people like OpenAI at that time, and we were heavily leaning into the companies that had these, huge, grandiose, impossibly large sounding visions on what AI could become. And, it's not like we had a crystal ball, but the reason we kind of drove so heavily in that direction was because we recognized that it fit the bill of interconnect would be valuable in that workload, and it would be one of the most important pieces of how that workload scaled. And if it did take off in the market, then that will become a massive volume driver. And so that's kind of how the application pivots happened along the way. And then, we could talk about what happened between 2018 and 2022, because I think it really took ChatGPT getting announced to throw fuel on the entire industry and really start to accelerate pulling forward the need for optical connectivity and silicon photonics and a kind of silicon photonics coming through high volume CMOS foundries and supply chains, which is where we're at now.
Yeah, I guess optical chip-to-chip communication and this kind of technology has spent a long time as a future technology, and finally now at GTC we've got Jensen Huang on stage talking about using optical communication between GPUs in the same rack. Obviously it's this huge validation for you, but does it feel like this is the turning point now where demand is going to come, adoption is going to come?
It is definitely different than any other time that I think in Ayar Labs history, and definitely in any other time since I've been involved in this field. And what do I mean by that? I'd say previous activities that Ayar Labs was involved in, we were getting built into a variety of really compelling kind of R&D systems. You had places like DARPA and the DoD and some kind of forward-looking commercial players investing in kind of driving the technology and looking at optical connectivity. But now we're at a moment to where the high volume kind of leading accelerator roadmaps are all building intercepts for optical connectivity. Mm-hmm. And it's a complete shift in the kinds of activities we're involved in the kinds of planning and the scale of the targets that we're aiming for. And I'd say the urgency of making sure that the entire supply chain is ready to ramp, and also making sure that we're solving all the problems that remain along the path to ramping. So there are absolutely things like we have to go prove out the reliability of these solutions. We have to prove out the quality of production at the scales that we're talking about, which has never been done before. But we feel that all of those problems are one, attracting an incredible amount of focus and attention, and and effort from, both Ayar Labs, but also our big commercial product partners and the supply chains that we're working with. And the inflection point that we really kind of are aiming for and where we see things adding up is, it's not this year, it's not next year, it's a 27, 28 kind of inflection point. But to really be bringing products into the market in volume in 27 and 28, well, we're on the critical path of that, like right now. So, there's a huge amount of activity happening, and it's different than any other time in the company's history. So I can say that for sure.
Yes, very exciting. Yeah, I mean, I guess you're not the only ones to have seen this opportunity. Maybe you guys saw it further back. You've been around for longer. Obviously, the competitive landscape for you looks completely different to how it did 10 years ago. There's other people doing different flavors of co-packaged optics or different flavors of optical tip-to-chip or die-to-die. You have startup competitors, you have Light Matter, Celestial, others, you have Broadcom, of course, in the mix. How do you see the competitive landscape for Ayar Labs today, and how has that kind of developed in the 10 years now that new people are springing up?
Yeah, no, it's a great question. And, I think maybe one, how the competitive landscape has changed. What has not changed, and one of the things that I point out first always when this question is asked is, the real incumbent competition are high-speed electrical links, and it's copper. And so and everyone knows the technical value proposition that optics achieves over copper, but I think we don't understate the fact that you've got copper shipping in huge volume today, and what has not been accomplished yet is really bringing silicon photonic and electronic photonic solutions shipping in that kind of volume integrated into chip scale kind of advanced package integrations. So my first response to that question, and to some degree this is what I coach inside of Ayar Labs as well, we've got to be heads down making sure that we're actually bringing forward a product that meets both the technical performance requirements, but also the supply chain scale, the resilience of that supply chain, the reliability of how it operates in the field. We're solving all the problems of making it as easy as possible for customers to integrate into rack scale solutions. So that's where we tend to focus is to say, job number one is to really prove that the new kind of optical I/O that we're building can bring all of its phenomenal technical advantages, but match the commercial scale and maturity of where copper's at today. Now, on the optics landscape, yeah, I think you're right. If we went back 10 years ago, all the optical people were building pluggable transceivers. And so we never really deemed those players to be our competitors because we weren't building pluggable transceivers.
Yeah,
and so,
true.
That's how we kind of differentiated things at that time. Now, if we flash forward to today, yeah, there's big companies, there's startups that are absolutely, realizing the vision of what we've been working on for a long time, and realizing that this is going to be a huge opportunity and it's needed, across the entire compute stack over time. The main thing that I think about there is that one, it's a big market validation. So if 10 years ago there was not good market validation that the industry needed optical connectivity in the kinds of ways that Ayar Labs was talking about, now there's no question. And then I'd say, we view it as, on the technical side, there's layers of hard problems here. I think some people think that, hey, just because you see a process at TSMC or a process at GlobalFoundries or a process at Intel, and we use some of the same words like PDKs that the CMOS industry is used to, a photonic PDK is nowhere near what people kind of intuit whenever they hear the word PDK. So, you hear a CMOS PDK and you expect that you can go run an ASIC flow to go build things. Photonics PDKs are nowhere near that maturity right now. So it's a heavy involvement between a company like Ayar Labs in the foundry and some of the first customers that we're getting designed into. And then there's layers and layers and layers of hard problems that you have to solve. And a lot of them are not the kind of flashy problem that get a lot of fanfare for breaking a new speed record or or whatnot. It's very practical problems in the manufacturing, the assembly, the test, how these devices behave in reliability, these kinds of things. So I think part of it is we feel we've accumulated 15 years of battle scars, let's say, of trying to make all this stuff work. And we think that we're probably the best set of technologists because we've been at it for so long. The other thing I'd say, though, is we hear a lot from our end customers that they really want ecosystems of optical connectivity solutions to emerge. Mm-hmm. And so I think it's a very compelling story to some of the end customers that someone like Ayar Labs is we're an independent optical solutions provider. We're not trying to bundle it with our own accelerator. We're not trying to bundle it with our own ASIC services. We're not trying to bundle it with our own fabric solution that takes over the entire rack architecture. We're developing optical I/O chiplets and external laser modules and optical I/O connectivity solutions that can integrate into a variety of different endpoints, whether that's a big company's accelerator or a hyperscaler's accelerator or a smaller startup or mid-sized company accelerator. And also, we can talk about it, both integrating with accelerators, but going back to what we worked on with that Nature paper 10 years ago, we think that we're going to see optically connected memory become an interesting thing to work on. And that goes kind of back to the days that we were working on it from 2010 to 2015. And of course, what's already happening is optically connected kind of switching fabrics. So between GPU to GPU, GPU to memory, GPU to switching fabrics, we think that there's a huge need for an ecosystem solution of optical chiplets and optical I/O providers, and end customers really want that. So again, there's kind of technology differentiation and there's business model and go-to-market differentiation as to how we think about the competitive landscape.
Yeah. So you're a co-founder of the company. You've been with the company its entire time, so 10 to 15 years, 10 years officially. You became the CEO at the end of 23. When you took over as CEO, what did you personally aim to do with Ayar at that stage? And how do you see your own role as it's morphed from kind of the science back in the day to the CEO where you are now?
Yeah, no, it's a great question. And maybe one way to answer that is if I put myself back in 2015, 2016, what was I spending my time doing? And, I set up our first CAD servers at Ayar Labs. I set them up in my apartment in Berkeley, and I taped out our first chip. It was called AL1, so Ayar Labs 1, and I was a one-man design team. And so it was a very simple chip. It wasn't a complicated chip, but that was kind of what I was spending my time doing at that time. If I flash forward to now, where do I spend my time? I spend my time with our biggest customers. I spend my time with our supply chain partners. I spend time with kind of important investors and capital markets folks. And of course, I spend a lot of my time internally as well, driving execution, making sure we're building and scaling the company in the right way. So yeah, that trajectory has been a very fun trajectory, I'd say. And it's shifted how I think about things. It's shifted where I spend my time, what I focus on. And some people are surprised by kind of that trajectory. But I'd say the thing that's been consistent with me throughout is I've always set the problem statement as what's the most important thing to work on at Ayar Labs at any given moment. And then I go try to spend my time on that thing. And so, I think if you have that mindset, it tends to kind of broaden your scope. And there were times where the most important thing was 7 days a week, 18-hour day chip tape out. Yeah. And then there are times when the most important thing is we're running out of money. We need more capital, and I've got to be on the road raising money. And I think you accumulate those experiences over the years, and you really have a kind of broad perspective. Now, stepping into the CEO role and the vision going forward, really that was also timed with a moment in time when we really redoubled our focus on saying, the volume inflection for optical I/O is happening, and it's being driven by the large scale AI workload. And we've put ourselves in the perfect position with the previous 10 plus years of how we've been working on this technology, how we've been building our supply chain relationships, the strategy we've been executing under the hood, now's the time to just go all in on it and give it everything we've got. So that's kind of, let's say, the simple story of how I stepped into the CEO role, and we're driving a pretty singular focus in the company right now. We're getting designed into high volume accelerator roadmaps. An incredible amount of progress is happening through volume supply chain ecosystems, and we're kind of heads down at the company right now, trying to make it all work. And so that's what we're excited about.
So I was going to ask you, like, what's coming next for Ayar Labs? Like, what do you hope you're going to be doing in 10 years' time? Or what do you hope Ayar is going to be doing in 10 years' time? But 10 years is like 100 years in semiconductor years, which I guess in AI years is like 1,000 years. But if it's not too distant to think about what you might be doing in 10 years, what do you think is coming in the 10-year time frame for you?
Yeah, no, 10 years is, I think it's a reasonable amount of time to think about, because what it really draws in my head, so the picture I've got in my head for 10 years from now, we're going to go through an inflection point in 27, 28, where the largest customers are driving a new paradigm of optical connectivity in large scale compute. Ayar Labs will be a leader in that transition, and coming out on the other side of that, we're going to see just a huge proliferation of the need for optically connected solutions, not just with the biggest players, but across the entire industry. And then as we get into the 2030s, even though I do expect large-scale AI to still be the largest singular market application, we're going to see optical connectivity propagate into a bunch of other application segments as well. Telecommunications, aerospace, and kind of satellite, and classical kind of defense type applications. I still think it's going to be a while before we see it in consumer devices. That's my own opinion. So even within a decade, I'm not sure it makes much sense to think about these kind of high bandwidth solutions and things like cell phones. But in 10 years from now, I'd say Ayar Labs will be a household name in semiconductor parlance, and we'll have been a company that emerged as a leading optical connectivity company. So that's the kind of the vision that we have, and we think the industry needs it as well, and the market is massive over time here. So yeah, that's what we're working on, and that's how we see the kind of 10-year vision unfolding. But critically, it passes through this kind of 27, 28, 29 inflection point.
Okay, we're still in the inflection point until 29-ish.
That's right, and that's right. And I think it'll be obvious if we're successful in that time period. I think you're going to see a new generation of optically connected racks, right? Yeah. So that'll drive so much downstream. Yeah, absolutely.
Okay, final question then. What would you say to someone who's thinking of starting a deep tech or a silicon-based startup today? To that PhD student, maybe they're working on something they think has commercial value. Should they go for it? Would you recommend it?
Yeah, I think my answer to this question has changed over time, and I don't think I've got a perfect answer to it. But kind of going back to what we talked about earlier, I'd say what you're doing is nearly impossible. Most likely it will fail. A successful startup experience will challenge you on every layer of who you are, personally, professionally. It's going to force you to grow at a rate, personal growth at a rate that right now you can't imagine, and almost certainly you'll fail. And again, I think the people who are freaked out by that, it's a good filtering to say it's probably not for you. But
yeah, if you can't deal with the failure, maybe think twice. Yeah,
that's right. And all the stress and the kind of growth and the ups and downs that come with it. But the ones who say, hey, I don't care what you're talking about right now, I'm not listening to any of your advice, I'm just going to go for it.
Yeah,
I think that's a decent filtering on the ones who want to go for it. And then the ones who want to go for it, I really applaud the kind of entrepreneurial effort, and I'm a big fan of founders. And I think I try to spend some of my time now giving founders and entrepreneurs whatever advice and help that I can give. And so I'm a huge cheerleader of anyone trying to go down this path. I just think it's a very challenging path for sure. Challenging but rewarding. But rewarding. If you can make it through it, you'll grow. You'll become a different person. You'll get to work with people that are incredibly rewarding and fulfilling to work with. And so there are rewards along the path. But I think that the level of grit and resilience required is extreme. Yeah.
Well, that's the perfect place to finish. Mark, thank you so much for coming on the show, and congratulations again on 10 years of Ayar Labs.
Yeah, thank you.
Thank you so much to Mark for taking us from the early days of Ayar Labs through to today on the company's 10th anniversary. That brings us to the end of the episode. Please tune in again next time for more conversations around AI silicon and systems. If you're listening to this on the podcast page at eetimes.com, links to articles on topics we've discussed are shown on your left. AI with Sally is brought to you by Aspen Core Media. The host is Sally Ward-Foxton and the producer is James Eade. Thank you for listening.